people who are terminal sort of, could die 6 months down the road, could die a month later. In various circumstances, are more likely to die sort of after a big event. But sort of this, so what we find, and I think, if in the way you're sort of the best way to answer before we expect what 25% to die within 3 months if it's just random, which a lot of us would expect. Well, we'd find dying the day or a week after your birthday, but why 3 months? So we expect it to be 25%. And so if these are equal, then we would say there's no difference. If they're different, then we would say there is a difference. And if you then calculate the number out, was it 46% or something? Is that what it was? Like 46%? And actually, I thought that ends up being 0.21 divided by 0.0158 or so, or like 13 or something like that, 12 or 13, some big Z, right? Well, what that's telling you is that this almost couldn't have happened by random chance. That we're not 100% sure that the null set. This is like whatever, some big.
Can you run through what that equation is again?
Oh, Z is equal to Z, and since our sample size is reached about 30, Z is equal to P minus pi divided by the standard error. Standard error being what was it, 739 sample size, and it's what's 730, 747. And if you know the underlying population expected percent, it's better to use the population percent. If you don't know, it's better you can use the sample.
So pi was 0.25 because you expect because it's a quarter of the year.
Quarter of a year. But no huge big deal if you put in the other number. In my world, my class, But then, as sort of a person, what I'd ideally want for the answer is sort of do some calculate a Z. Say the probability that the null is true is sort of almost is point whatever. Very small, something small, because you can't actually calculate with the tables the p-value that small. So know that, but then ideally I'd also like you to sort of say, well, in this one case it seems remarkable, but I'm not so sure. I'd want to retest this. I'm not so sure I trust the data collection. Was it really a random group of deaths? Because this is a pretty stark sort of difference. And it's something, it seems like we all should know about this somehow. If we knew that sort of in general. And you could also sort of pull back to if you wanted to even get better at it, you could pull back to that idea of external validity and go, well, maybe this only happens in Utah. These birthdays mean, because there's always that. I mean, that's sort of, if you want to sort of say something intelligent about it statistically, you'd give me a little sort of calculation, and if the outcome is kind of surprising, wait, a huge percent of people, and it's for sure, if this is a random sample of deaths in Utah for a much higher percent than what you'd expect are dying within 3 months of their birthday. You could accept that based on this data, or you might question sort of the data itself at that point. And so you might want to you do that, and then you might want to also question the data itself. But you probably get full credit if you sort of did that and said, yes, this is remarkable, and the probability that the null is true is really, really small.
In a sense, in statistics, if it seems too remarkable, it probably is too remarkable, and there is a problem with that.
Yes, and certainly for a policy person, yes. I mean, it can be true, but then you go,